Software development is a very important process, and one of the most important parts of it is often overlooked. That is the version controlling of the source code. Now, version control is very important in software development because it allows us to manage, maintain, and store the source code of our software. Now, one of the most popular tools used for the version controlling is Git. It is used very widely in the industry by software developers, by automation developers, by school students, by professors, even amateur hobbyists who working with code. So in this video, we'll be detailing each and everything you need to know to get started with Git, all of the things, and even more. Also guys, here at Great Learning, we're coming with something really awesome called Great Learning Academy, where we are providing more than 80 plus free courses in which you can go ahead and enroll and earn a free certificate for yourself. Now you can do this by heading to our website, greatlearning.in/academy, or downloading our mobile app and enrolling for the courses from there. And guys, before we begin the session, please don't forget to hit the bell icon and subscribe to our channel to not miss out on any of our future content. So now let us begin this video. Source code management with Git. So guys, we'll be learning about source code management or version control system using the tool Git. Now, this is a very integral part of DevOps as it is a part of continuous development phase, which is again a part of DevOps. So let's go ahead and look at the different topics we'll be covering under this topic. So we have what is version control. We'll understand what version control itself is. Then we'll see the need for a version control system. What are the different version control systems available? Then Git overview. We'll talk about why Git, what Git is. Then we'll get started with GitHub. Then we'll learn how to install Git on multiple systems and configure them. Then we'll basically learn the Git basic commands. Then Git branches, merging, and Git workflow. So these are the different topics we'll be covering when we are talking about source code management with Git. So let's get started. What is version control? So when you think of the word version control, what comes to your mind? Well, as the name suggests, it's version control. You control the different versions of a thing. Now, when talking about this with software development, right, it is important because you have to version control your software. Now, in software development, you write source code. This source code is then used to create a software. Now, you will definitely have multiple versions of a software. To have those multiple versions of software, you'll have to have multiple versions of the source code. And that is where version controls comes in. Now, these days when software is developed, it is not developed with the mindset that there will only be one piece of code that will be deployed, and that's it. You will definitely be writing multiple lines of code and multiple versions of that code because you will definitely try to improve upon your previous code, and to improve upon it, you will write new versions. Now, these days, smaller snippets of code are deployed in regular successions with regular feedbacks. So what this means is that you write small pieces of code, you push them, and you get a feedback, whether it's from your team or whether it's from the end user, and you improve upon that code by writing newer versions, and they are again smaller snippets. So this way you're writing many different versions of a code, improving every time you write a new piece of code. This leads to many different versions of the code. And that creates a need to organize the code and all of its different versions of it. This is where version control comes in. You have to control the different versions. So version control is basically a practice of managing and storing different versions of code. Now, if I were to give you guys an example, think about a college student or a school student who has to do his final year project. And he has finished his final year project. So he's doing his project in, analyzing how a particular website processes a certain thing. Now he's completed his work and he has made sure he's documented everything, and he's written down everything that is related to the code. Now he's on the deadline because that's the last day and he's finished his work, but he feels like he can do better things. He can improve upon his existing project because he feels like he needs a better grade, and to get a better grade he needs to show his professor that he's done his best, and he's done his best in every other part. So he sees that there is a need. He tries to identify if there are any problems with the already existing project, and he sees that yes, there is. He sees that he can optimize the processing part of his project even more. Now to do this, what he does is that he writes the new code for optimizing the whole project over his old code. When he does this, he takes a lot of time. Maybe he takes like 4 or 5 hours or maybe 6 hours, and he sits down in one place and does all of the changes. Like he makes all of the changes, and once he's done making all of the changes, he tries to execute the code. But this is where a problem occurs. The code doesn't run properly. Why? Now he doesn't know why the code doesn't run properly. So what should he do? Should he panic because like the next day is the deadline? He has to go and show to his professor what he's done, and he can't show anything because he has a project that is not running. The mistake over here that he made was overwriting his previous code. If instead what he had done was write the new code in a separate file and back up his older version of the project in another file, in another location. This way, both of them don't interact with each other, and there are no conflicts or there is no overwriting. There is no miscommunication. If you suppose don't do well in your new version of the code, you can always go back to the old version. And that, in his case, he couldn't do that because he had overwritten his older code. So you can see what would happen if he had introduced version control system and how important version control system is. So this is one of the examples where you understand the need for version control, because you can always make mistakes, and if you make mistakes and you don't have time to rectify those mistakes, then you're gonna be in trouble. But if you manage your versions of different code, you can always go back to the different versions, the older version, the working versions. So this is especially the case with larger companies that have multiple projects and multiple teams working on them. So for example, there's a team that has a website for it's a shopping website, and they have multiple projects on it. They have project A, they have project B, and they have project C, and there are different teams working on them. There's team A working on project A, team B working on project B, and team C working on project C. And project A is for their payment feature, project B is for their shopping feature, and project C is for their cart feature or their warehousing feature, the backend, where all the items come in and get stored, the warehousing feature. So all you can see that all these different teams work on different versions and different features of the website. So let's examine project A. So project A is basically your payment feature, right? So there are 3 versions to it. There's A1, A2, and A3. Now the A3 is the latest version of the code. Right now it's not being deployed. The team is still working on A3. A2 is the one that has been deployed. Now A2 has been deployed for a good amount of time. The users have used it for around 6 months, and there have been no crashes. It's working perfectly fine. But you always have to make improvements on what you've done before. So the team identified the places where they couldn't make those changes, and they came up with the idea of A3, the latest version, and they're working on it, and they've actually done working on it, and now they're planning to deploy it. So what they do is they pull back A2 and they immediately push A3 as the latest version. But then they see that A3 starts crashing. They start crashing when the client enters a specific number or specific something. They haven't exactly identified the problem, but it crashes the whole website, and that affects the other teams also. So this is important. This is a grave mistake. So in this situation, what they can do is they can make sure that the application or the website that is provided to the end user remains there. Like this shouldn't happen that there is no application for the users to use. So to do that, what they can do is they can pull back A3 and push back A2 again, because A2 was the latest stable version that these people were using, and it was working fine for 6 months. There were no issues with it. So this way they make sure that their clients or customers have an end working product. While this is happening, while A2 has been pushed, they go ahead and debug A3. So they can go ahead and see what is a mistake made in A3, they can rectify it, and while they're doing it, there's no downtime for their final application. And this way project B and project C can still go on working without any integration issues. So this is again why version control is important. It helps you organize all of your code. It allows for greater collaboration between different teams. You can manage different projects at the same time. So this is exactly why people go ahead for version control. All right, so now we know what version control is. Now let's see, why do we need it? We've already discussed some of the reasons. So just as we discussed right now, the purpose of version control systems is, as the name suggests, it controls the different versions of the code. Now, how does this go with DevOps? So the idea of a version control system, or a VCS, meshes very well with the DevOps ideology. What is the DevOps ideology? We studied a few principles, but the whole goal in the end was to make the whole software pipeline as efficient as possible. And the idea of VCS meshes very well with that ideology. It helps us to make the whole software development as efficient as possible, because we're using a version control system where we organize everything. That increases productivity as well as efficiency, and it also allows us for quick delivery of code and automatic job triggering. So when you want to push a specific code quickly, you can do so because you already have version control system. So you can create triggers. You can create triggers in build jobs where the whole process is automated. This way, there's no human intervention always required. You can automate even more. So this is very integral for DevOps. This allows for easy automation of the whole software development pipeline. That's why version control goes really well with DevOps. Now, there are a few benefits to version control systems also. So let's study them. So it gives you complete control. So that is one of the big benefits of version control systems. A good version control system, or a SCM tool, will allow you to completely control all the aspects of the code that you are going to write. Why? Because you will have complete access to every facet of that code. Who's writing that code? Where is he writing, or when is he uploading the new feature onto the master branch? All those kind of details will be stored as logs, and you will have exact control of who has access to that code in the first place. You can control it, completely. No one who does not have authorization to access your code cannot access it. So that way you have a lot of control over your code, and you can create triggers. You can, create build jobs where you can put your repositories. That way also you have control. Then comes security. Now, implementing a proper source code management system creates a layer of security around the code and allows for only a need to know basis of accessing the code. This again relates back to the control benefit of a version control system, where you have a lot of control, where you know who is accessing the code, where you give authorized access to only a certain group of people, and where you have a list or a log of every change that is happening to the code, every commit that is being made. So this is why security is again a big benefit of version control system. To give you guys an example, if you had, let's talk about the previous example we took. Project A, Project B, and Project C were being handled by different teams. Now, the developers in Project A will not have access to the source code in Project B, right? Because that's not what they're supposed to be doing. So they don't have access to it unless there is some cross talk and they want to collaborate on a specific thing. So the team lead can give access to the developers in team A. So this is how it could work. Then it gives you the option of fast delivery. A good version control system also helps in fast building, testing, developing, and deployment of the software by being connecting to the deployment tool. So if you have any CI/CD tools, continuous integration / continuous deployment tools like Jenkins, you can easily deliver your product. So all you have to do is create a build job where you assign specific configurations, where it tells Jenkins or the CI/CD tool that it needs to pull the code automatically without any human intervention and push that code into the deployment or the production environment. So that way the amount of downtime you have for a specific application is reduced greatly. And if you reduce the amount of downtime for an application greatly, the amount of money that gets wasted when the application is down reduces a lot, and this in turn increases the revenues for the organization or the company. Then the last benefit that I want to talk about is availability. Now, availability is kind of related to reliability also. All the code, all the source code that is created is stored in a cloud repository. Now, basically, you will write features in your own local repository or your local system, but you will be pushing it to the cloud. Once you pushed it to the cloud, it is available to everyone who has access to it. So anyone from anywhere can pull the code into the system at any time without any issues on the planet. But even if there's a pandemic going on, or even if there is a whole natural disaster going on, or the society is going to collapse, you can still access the code as long as the servers that host that code are still running, and you need to have internet access, obviously. So these are the different benefits of a version control system. So what are the different version control systems available to us? So there are multiple tools for source code management or version control system or version control that are available to us for using. They're usually very similar with the exception of some features that cater to different requirements. So they normally are, your AWS code commit, GitHub, and Git, and your Mercurial with Bitbucket, and then you even have other versions for your Azure repository or your Subversion. So you have a lot of different options. Now, a lot of people definitely they go for Git or Mercurial because Git is actually, a lot of people just go for Git because Git is an amazing tool. We will talk about this a little later, but Git gives us a lot of different features. As you may have expertly deduced also, we are definitely going to be talking about Git and GitHub in this topic. All right, so let's talk about Git. Git overview. So what is Git? So Git is basically a version control system. We discussed that, and we know Git is the VCS. So Git is an open source VCS. It's an open source version control system that allows the user to keep track of all the changes that have been made to the source code of the software. So you have developer 1, developer 2. They are, independently responsible for creating feature 1 and feature 2. So once they write their feature 1s and feature 2, they go ahead and push it using the tool Git onto the GitHub. So the distinction between Git and GitHub here is that Git is the tool that helps you track all the changes, helps you do pushing and pulling, and GitHub is the dedicated storage repository which versions all of the code that is being stored. So this is how, this is what Git is. Git is an open source, version control system. Git's full form is Global Information Tracker. And, it was developed by a group of Linux kernel developers back in 2005 when they weren't satisfied with any of the free source code managers that were already available. Since they weren't very satisfied with what was available, they just came up with their own thing. That's how innovation happens. When there is a need, someone will create. There were paid softwares also, paid source code management systems also, but people generally wanted to use free ones because of their own use, maybe personal use, or maybe the requirements weren't fulfilling enough. Now Git and GitHub slowly became the industry standard as people gravitate away from legacy version control systems towards open source tools like Git, as they provided the same features, but it was completely free. So it was completely free. That this became a very attractive offer to many different people, especially like startups and amateur developers, because not everyone has the resources to pay millions of dollars for a software, right? And when you don't have that accessibility to resources, you tend to go for cheaper options. And being free is an amazing offer over here. So Git has that, feature of it. Now there are a lot of other features of Git. Let's discuss them. So those features are like, system compatibility. Now, Git has absolutely no problem running on any type of operating system, be it Windows, be it Linux, or be it Mac. Git is also great when it comes to inter-version control system compatibility. as it can work together, it can work with other tools repositories. For example, if you wanted to use Git with some other repository, not GitHub, if you wanted to use it with Bitbucket, if you wanted to use Bitbucket and Git together, you could do that, really. And if you wanted to use Git and SVN together, Git has no problem pulling and pushing code to and from distributed repositories of SVN or any other repository than GitHub. So it's got great system compatibility, not just with operating systems, but also with other repositories. Then comes collaboration. Now, Git allows for heavy collaboration. A team of developers or different teams of developers can maintain a hierarchy and work on the same main code but on different snippets of features simultaneously, and then merge all of their work when they're done to form the software that is to be deployed and be presented as the end product. Now, this allows for easy tracking of who's working on what part of the project and what changes they have made, which again, relates back to whatever details they have, whatever details have been or of changes have been made are stored as logs. Then comes speed. So speed is another feature of Git. Now, Git is very efficient at handling code and allows the user for easy forking and cloning of major repositories onto local system. So if you're working in a company and you're working in a specific developer team, and you want to pull the whole code into your system so that you can start working on a new feature, then you can do so very easily and very efficiently. It is also much faster than all of its alternatives. So if all the other alternatives like Mercurial and AWS Code Commit, it is much faster than them. So that is again a big thing about Git. And then another feature is distributed system and reliability. Now, this facet of Git allows multiple users to work on the same piece of code from anywhere in the world, as it is stored in a distributed repository accessible from the internet. This allows for companies to hire people without having to worry about their location, but rather their abilities. Not only that, people can start working from their homes. Work from home becomes very easy, especially in situations where you have a large pandemic at hand, where people can't travel to the office due to security and safety reasons. Then you can just rely on whatever is available on the cloud or the distributed repository. Just pull your code, work on it, and then push it back. So it removes any dependency on the location itself. You don't have any dependency on what your location is. That is a great improvement from before. This provides a sense of availability, as the code is always available to the developers. They needn't worry about the server maintenance or the upkeep of that server also. Unless you had your own dedicated server where you were storing all of your source code, you would access the cloud, and that is not maintained by your company. Or if it is, that is fine, but that's still not your job. If you're making use of any services that are provided by AWS or Azure or GCP, then they are maintaining those servers. So there is no upkeep for those servers. You just have to pay them, and they will guarantee the availability to you. And then the last feature I'll talk about is security. Now, we've already discussed this when we talk about version control systems, how they will create a layer of security. With Git also, you have the same. It keeps a track of all the changes and all the commits that were made as logs. This allows for easy investigation if or whenever any issue occurs down the pipeline. So if any issue suppose occurs down the pipeline and you want to figure out why that issue occurred, then you would just go ahead and check out all the commits that have been made to your master branch. And if you see that there are some issues, you can easily click on them and make changes accordingly. Now, Git is overall one of the best source code management tools that anyone can use. You can be a software developer, you can be a data scientist, you can be a student or a professor or even an academic researcher or even hobbyist. Everyone can make use of it because it's so easy to learn and it's so easy to use that anyone can make use of it. Even if you're not using it for software development, you can even use it for just storing your files. It's just amazing. All right, so now we've understood a lot of things about Git and version control systems. Let's understand how the code flows within the Git system itself. From so far what we have learned, you can probably deduce that you will write the code on your system and that code will be pushed onto the distributed repository or the cloud, which is exactly what is happening in Git. But there are a few steps that we didn't mention. Now let's start talking about those steps. So the first step is assigning a working directory. So first, a working directory is assigned. So this working directory is basically the location where all of the working code will be stored, and this is where the user will be working from. So suppose in your system you create a folder called project folder and you start working from that project folder, then that project folder, like you store all of your code like index.html, index.js in that project folder, then that project folder is your working directory and you have assigned it. So like there's no official step, but you are assigning it as a working directory. Then comes the next step in this life cycle, that is initialization. Now this is a step that you will be doing using Git. So once you have assigned the working directory, the next step is to initialize that working directory. So to initialize, once you initialize that directory, you basically tell Git that this directory or that folder called project is now to be regarded as a local repository, which can later be pushed onto the distributed cloud whenever there is a need. So it's basically telling Git that this folder is the folder that I want to work with, and please keep a track of all the files that are staged and unstaged. This is when Git basically starts tracking all the files in the directory. So then comes the next step, that is staging. So once the initialization has been completed, the work on the code can begin. All the changes that like addition or deletions are made. So once you've made those changes to your code, right, you already might have some code like index.html. You make those changes in that code, and then you go ahead and stage that code. So you'll basically be working on the code between initialization and staging. So staging is basically telling Git that what are all the changes made to a specific file. So you can stage a specific file, and then Git will basically automatically identify what were the changes made to this file compared to the previous version. This is when Git starts checking for all the changes that have been made. So this is staging. So once you've staged, you go to the next step. So in the local storage, right, you're going to be committing. So once the work on the code is done, once you stage the files are then committed. So committing basically means that you're saving the changes that you've made. So suppose in that index.html file, you made a change where you added some header tag and some paragraph tags, and you want to save those changes onto your local system. Now you can just control S it, but to inform Git about the saving that is done, you need to commit them. So once you commit them using Git's command, that save will be changed as a specific commit in the local storage. Now that you've done all the work, it's in the local storage. The next step is to push it to GitHub or the local or the distributed cloud. So then the code is pushed from the local storage to the cloud or the distributed repository. With Git, it's GitHub where the code is stored. So this is the life cycle of code within Git. So it goes from working directory where you assign one working directory and you start creating all the files inside that working directory. Then you initialize that folder/directory, and then you start working on that code. Do whatever you want, make all the changes, and then once you're done making all the changes, stage whatever file you want. If you have 3 files in the system and you only want to push 2 of those files out of those 3, then you stage only those 2 files. And once you stage those 2 files, all the changes are tracked by Git. And once you've done staging, you can go ahead and commit that code. So once you commit that code, all the changes are saved on the local system. They are stored in like those track of those changes are stored in a commit, and basically then you go ahead and push the code to the GitHub. Now the code can be later be pulled on to make newer changes, and this whole cycle will be it will start repeating again. So this is the life cycle. Now let's get started with GitHub. When we talk about Git, it is important to also mention GitHub, as GitHub also plays a major part in this source code management. Now the job for source code management is usually divided in this way. You have Git. So Git is the tool that tracks all the changes. It pulls and pushes the code, solves any merge conflicts or does any merging or rebasing. And GitHub is the one that is responsible for storing all of the code. It's the distributed repository which stores all the code. Now to effectively use Git, we need to know how to use GitHub also. So let's start by creating an account on GitHub. Head to github.com and there fill out the form in the sign up like so. So let's start doing it. So committing basically means that you're saving the changes that you've made. So suppose in that index.html file, you made a change where you added some header tag and some paragraph tags, and you want to save those changes onto your local system. Now you can just control S it, but to inform Git about the saving that is done, you need to commit them. So once you commit them using Git's command, that save will be changed as a specific commit in the local storage. Now that you've done all the work, it's in the local storage. The next step is to push it to GitHub or the local or the distributed cloud. So then the code is pushed from the local storage to the cloud or the distributed repository. With Git, it's GitHub where the code is stored. So this is the life cycle of code within Git. So it goes from working directory where you assign one working directory and you start creating all the files inside that working directory. Then you initialize that folder slash directory, and then you start working on that code. Do whatever you want, make all the changes, and then once you're done making all the changes, stage whatever file you want. If you have 3 files in the system and you only want to push 2 of those files out of those 3, then you stage only those 2 files. And once you stage those 2 files, all the changes are tracked by Git. And once you've done staging, you can go ahead and commit that code. So once you commit that code, all the changes are saved on the local system. They're stored in like those track of those changes are stored in a commit, and basically then you go ahead and push the code to the GitHub. Now the code can be later be pulled on to make newer changes, and this whole cycle will be it'll start repeating again. So this is the life cycle.
Hey guys, let's take a break. Go ahead, pause the video, grab something to eat, drink some water. We have a lot more to cover. And also, guys, don't forget to like and subscribe, as this helps us to reach out to even more people like you. Now, let us continue with our video.
Now let's get started with GitHub. When we talk about Git, it is important to also mention GitHub, as GitHub also plays a major part in this source code management. Now the job for source code management is usually divided in this way. You have Git. So Git is the tool that tracks all the changes. It pulls and pushes the code, solves any merge conflicts, or does any merging or rebasing. And GitHub is the one that is responsible for storing all of the code. It's the distributed repository which stores all the code. Now to effectively use Git, we need to know how to use GitHub also. So let's start by creating an account on GitHub. Head to github.com and there fill out the form in the sign up like so. So let's start doing it. So I will open up my browser. So head to your browser, just type in github.com. And when you do type in github.com, if you already have an account, it will directly redirect to your account. Like I already have my account over here, so this is my home page. But if you don't have an account, what this is the page you will get. Let me just open up incognito mode and type in github.com. And when I do this, I will get another page. In this page, it will ask me for signing up for GitHub, and this is what you guys should see also if you don't have a GitHub account. So just go ahead and enter any username. So I'm gonna put Jane 4556, and I'm gonna type in some 4556 at gmail.com. Please go ahead and enter your email address over here and your username. Email is invalid, already taken. So let me add another 6, and it's valid. Okay. So, and I'm gonna give it some random password. Yeah, so I've given it some random password. Make sure it's a little bit strong. Yeah, and then you can go ahead and click on sign up for GitHub. So when you do sign up, it will ask you to verify your account. So make sure that you're not a bot. So to do that, it's not loading it yet, but it probably will ask you to move an image of an animal in the straight location, like in a vertical manner. So it should be in the right orientation. It will ask you for that, and you have to solve basically a small puzzle, and then you can verify your account. And we get it verified from your Gmail also. All right. So once you've finished all your joining in formalities, you can click on join a free plan. Okay, it's not doing that because I've not entered a right password or anything, right email address. So when you do join in, this is what you should see. You will see this as your home page, and you can see this is my page, and I can see my profile, my repositories, my projects, my stars, my gist. So if I want to search for someone else's repository or some other person, I can do that over here, right? So right now you can click on your profile, and then you can check your profile out. If you want to change any details in your profile, you can go ahead and do that. You can see this is my repository. I have 2 repositories right now, 3 repositories right now. I can create a new project if I want, or a new repository if I want. So let me just go back to the home page and show you guys how to create your own repository. So if you guys remember, I said that you can create your own repository, and you have 2 types of repositories: your local one, the one which you store over here, and your remote one that you store in your cloud. So this is going to be the cloud or slash distributed repository where you're going to store all your code. So to do that, just go to left hand side over here. There's a button to click on new. Click on new over here. Once you click on new, it will give you a lot of options, right? So it's going to ask you who's the owner. You can change the owner if you have multiple accounts. If you want to, you can give it a name. So let me give this a name. I will give this a name. My demo website. Let me just normalize this. Yeah, and let me spell website correctly. Yeah, my demo website. So this is the name of my repository. I can go ahead and give this a description. This repo will store all the source code that will run my website. This is my description. You can make it public, or you can go ahead and make it private. I'll leave it public so you guys can go ahead and check this repository out. Then once you've done that, you can initialize a readme. So readmes are basically explain what your project is about or what your repository is about. So if you're creating a specific package, you can create a readme, initialize it, and add whatever you want. But we don't need to do that right now. So I'm just going to go ahead and click on create repository, and this will create a new repository for us. So once we do create a new repository, the most important thing you have to take in consideration over here is the URL. This is the one URL that you will be using. So if I copy paste this URL into my browser, I should get access to this repository. And I do get access to it. So this is an important one. Copy and keep it, or just remember whatever your name is, github.com/username/repository name. And you can see there are a lot of details over here to take in. One of the details is it helps you create a new repository command line in your local local system, push an existing repository, or import code from another repository. You can check out issues, pull requests, actions, projects, wiki for security, insights, and settings. So there are a lot of options over here. You can see GitHub is full of different features. You can create webhooks. You can perform a security analysis, check integrations, and etc. etc. And this is where your code will be stored. All right, so we've created our own repository. We have created our own account and our repository. So this is what we will need for now. So let's move on to the next thing. Now we will install and configure Git, because we want to work with Git. So Git is a two-man source code management is a two-man job. It's with Git and GitHub. So let's go ahead and install Git. Now you can install Git on any of the various different operating systems. Like I mentioned before, it's independent. It works independent of the operating systems. You can work with Linux, GitHub on Linux, GitHub on Windows, GitHub on Mac. So I'll explain how to download GitHub on Linux and Windows. All right, so I will go through these process more briefly, comprehensively. All right, so let's go ahead and do it for Windows first. Then we will do it for Linux. So let me go back to my browser over here. We'll close these. All right, so open a new browser, new tab, and type in Git download. So when you type in Git download, you should click on the first link. It will be gitscm.com. Just click on that, and it will give you various options. It will give you options for downloading it for Linux, downloading it for Windows, and downloading it for Mac. So the one we will choose is downloading it for Windows. So let it just load. All right, so we're going to go ahead and click on Windows over here. You can directly click on download 2.2.8 for Windows. Now, once you click on Windows, it will automatically start downloading it. So you can see Git 2.28.0 64-bit is downloading. If you have a 32-bit system, go ahead and click on 32-bit for Windows setup. Just wait for this to get downloaded. All right, so once the .exe file is downloaded, you can go ahead and click on it. If it does not automatically download, you can go ahead and click here to download manually. So once the executable is downloaded, go ahead and start it up. I'm going to click it over here. It start opening Git installation wizard. Now in the installation wizard, it will ask us a lot of things. I want you to leave most of them default. All right. So when you have the installation setup up here in front of you, just keep on clicking on next. Make sure you have it in the right directory. You can change it if you want, but I would recommend just keep on clicking on next. Leave everything default. because you're new to Git. If you're not, you can go ahead and change them. If you want to change the editor, you can change it to Sublime, Atom, or whatever you're comfortable with. Visual Studio. We'll leave it as Vim here. I'm gonna keep on clicking on next because these are advanced configurations, and usually the default one is fine. I'm gonna click on next. I'm gonna click on next, and I'm gonna wait for it to download. Install. As you can see, it's starting to install Git for me. So we'll just wait for it to install. So once your Git installation is completed, you can just click on launch Git Bash, or I'll show you guys how to launch it manually. So just click on next again. Once you're done installing Git, you can right click anywhere. I'll show you guys. Just right click anywhere on the screen or any folder, and you guys will see two extra options over here. So Git GUI here and Git Bash over here. So Git GUI here is basically Git graphical user interface, and Git Bash is basically a terminal. It's the Bash terminal that if you're acquainted with the Bash terminal, you can go ahead and use the Bash terminal. If you're acquainted with the GUI, you can go ahead and use the GUI, whatever you're comfortable with. So this is the GUI. Alright, so you can see it tells you all the unstaged changes, whatever is missing. Stage changes will come in. Alright, so this is good, but the terminal is better. It makes you look cool also. If you have any friends who don't know anything about computers, you can show them you're like a hacker if you use the terminal. And the terminal is a lot easier for me also, because all the commands that we use for Git, they're easily doable using the terminal. And if you're working with an integrated development environment where you're writing the code in an integrated development environment, you can basically make use of any Git plugins. So if you're working with IntelliJ or any other integrated development environments, they all have their own plugins for Git. And Visual Studio Code has Git embedded in it, so you can definitely use it like that. So guys, this is how you would go ahead and install it. Git in Windows. Now let's go ahead and do this for Ubuntu or Linux. Since I'm going to be using Ubuntu because it's one of the most used Linux distros out there, so let me go ahead and open that up. So I'll be using an AWS instance over here. As you can see, I've already launched one instance, Ubuntu instance. Let me just rename this to Git. All right. So I'll explain to you guys how to, basically launch instances when we're talking about Docker, since we'll be talking, using these more intensely. Right now, I just want to show you guys how to install Git on a Linux system. So while this is loading, let me open up my PuTTY tool. This is my SSH tool. It will allow me to connect to that instance. I just need the IP address. Let's finish it loading. All right, so let's go ahead and copy the IP address over here and paste this. All right, so let me go ahead and paste this over here, and we will open it up. All right, so let me log in. Okay, so we are now logged in. Right, so we are logged into Ubuntu instance. So there are two ways to install Git on Ubuntu. You can go ahead and use one of the Ubuntu repositories itself, or you can use, download Git directly. Now, downloading Git directly is a little longer procedure. It will give you the latest version of Git, but mostly Ubuntu repositories are also updated with the latest version, mostly, right? So there'll be like, maybe one version late or something. That's it. So to install Git, what we're going to do first is we're going to go ahead and update this instance. So to do that, I'm going to use the command sudo apt update. This will update my Ubuntu repository in this particular instance. And once that completed, I can go ahead and install Git. So the command to do that is sudo apt install Git. Now, the thing with the instance that I launched with AWS here, that Git is already installed. So if you have an Ubuntu system that you're using, instead of using an AWS instance, you wouldn't have Git installed already. So you can go ahead and type in this command. Or if you're using the AWS instance, it will already be installed. So you don't really need this command. But I want to show you guys nonetheless. So if I press enter, it will start installing it, but it's already there. So if you want to do it in CentOS or RHEL, the command for that is sudo yum install git. So this is the command for CentOS and RHEL. So if you're working with that. Alright, so now that we have git installed, we can go ahead and use the first git command. The first git command is basically git hyphen hyphen version. So it will give us the version of git that is being used there. So we have git version 2.17.1. Alright, so let's go ahead and do the same over here. Let's check it in the bash. Let me increase the font size so it's more clear to you guys. Alright, so this is the different version for Windows and this is the version for Ubuntu. Right, so now that we've installed Git, let's go ahead and configure Git. So to configure Git, what I try to say is, I'm basically going to be entering the username and the password, the username and the email address. So let me show you guys how to do that. So here, what you will first do is, you will type in git config hyphen hyphen global. This global tag basically tells that these settings should be there in the whole system. Then I'm going to type in user dot name, and you can type in whatever your username is. Since mine is Remy code, I'm going to enter this, and then git config global user dot email, and you can enter your email here. Now let me just show you guys what what email are you going to enter. I mean, you can enter your email address, like if your email address is jane5446@gmail.com, go ahead and enter it. So right, so then you can go ahead and press enter, and to check whether your settings have been saved or not, you can type in git config list. This flag will list all the configurations that have been made. So just check for a username, user.name and user.email. So this has been configured. Now if you wanted to change them, all you have to do is type in these commands again and change the value. So to exit this, just type in q and you will exit. Same thing over here. You can go ahead and type sudo git config hyphen hyphen global user.name and then the name of the user. So my name is here again, Remy. So quote and enter. And I'm going to do the same thing again for my email address. Dot email, and I'm going to enter my email address. It is jane4556 at gmail.com. Right now, if I wanted to see the list of configurations, I would use the same command, but just with sudo git config and the list flag, and you can see the list of configurations for Git over here. All right. There's another way to do this. You can use the Vim editor. Go over here /git config. You can see the configurations in your git config file. You can come out :q. We'll use the same command in Windows also. You can use the same command v git config. All right. So let me just exit out of here. All right. So those were the basic configurations for Git. So now that we're done with that, we can move ahead to the next topic. That is basic Git commands. So let's go ahead and learn all of the different basic Git commands. All right. For all the Git basic commands, we'll be using the Windows version because it will give you guys a much better idea of how to work with Git. And I know a lot of you are inclined towards using Windows, so let's go ahead and use that. All right. So our first step here is going to be opening up our Windows system. So guys, here what we want to do is we want to use all the different commands. We have to understand what are the different commands that will help us achieve the Git lifecycle. So if you guys remember, we had to first create a working directory, assign a working directory, then initialize that working directory, then stage all the files, and then commit them, and then push them to GitHub. So that's exactly what we're going to be doing here today. So first, we will create a folder or a working directory. To do that, we will use the mkdir command. So I will type in over here mkdir, and I'm going to type in the name of the file slash directory I want to create. So the directory I want to create is called project. Now you can use the same command for Linux also. If you're working with Ubuntu, you can use exact same commands because they're using the bash terminal. All right. So I'm going to go ahead and press enter over here, and this will create a file or folder called project. So to check that, I can type in ll over here and it will show me all the files, and this is the file I created. So I will head into that file using the cd command. So cd project, and I am now inside the file. So you can check the address or the location or the directory over here. All right, and this tells you what branch you are on. We will discuss branch later. Let me just clear the screen. All right, so the first step is completed. We have assigned a working directory. So we will be working inside of this directory. Any files that we create inside of this, they will be part of the working directory. All right, so our next step is to initialize this directory. So if I type in git init, this will initialize the directory. So if you remember what initializing did, it basically told Git that all the files are to be tracked in this particular folder. So if I create any file, suppose I create a file called, I use the command touch index.html. So now this file will be tracked. So it will tell us whether these files are staged or not. So if I type in git status over here, so it will tell us that these files are not tracked. So basically, it will tell us that whether these files are staged or not. All right. So let me clear the screen again. And now we have an unstaged file that is index.html. So let's go ahead and enter some values into this index.html. So I will type in nano. You can use V also, but nano is a little bit easier. So I'm going to type in nano index.html. It will open the nano editor for us. All right. So inside of this, we will enter the code file. So I'm going to put some HTML code. All right. So then I'm going to give it a header. And then I'm going to end it. All right. So we have our sample HTML file over here with a lot of tags. So let me go ahead and save it. To save it, I'm going to type in Control O and then press enter. All right. So I saved it. Now to exit this file, I'm going to type in press Control X. So this will exit my file. Now to check the contents of my index.html, I can again press nano, but I'll just use the cat command. So it will list everything inside of index.html, and you can see these are the contents of my index.html. All right, now that we've created, we have added some basic code to one of our files, we need to go to the next step. So we've worked on our file. Now our next step is to stage this file. To stage this file, we have to go ahead and use the git add command. So there are two ways to do it. I can type in git add and type a dot. So dot will basically stage all the files in this particular folder. But if I want to, basically only stage one file, then I have to mention that file's name. So I'm going to mention it index.html, right? Okay, so if I press enter, it will stage the file. So if I do a git status again, so remember git status is to check the status of the local repository. This is my local repository. All right, so let me press enter. All right, so no commits yet, but there is a new file called index.html, right? So our next step here is to basically commit this file. We have staged this file. Now we have to commit this changes made to index.html into the local repository. So we have to use the git commit command for that. So I'm going to type in git commit, and this is the syntax for it: git commit, write git commit, and then write -m. So this is for adding a message. You have to add a relevant message to whatever commits you're making. So you remember what you did. So what did we do here? We added a HTML file. So I'm going to write here added index.html. All right. So I'm going to press enter, and it will tell us there's a commit made. Added this is the commit message. Added index.html, one file change, 8 insertions happen. Okay. So see, you can see that it tracked all the changes that happen. Now if I do a git status again, it will tell us that on the branch master nothing to commit because the working tree is clean because we've made all the commits. So there is only one file which has been committed. So our next step is to generally push this file onto our remote repository. Okay, so now we have committed our file. Our next step is to basically upload it. So we have a repository. Let me show you guys. So this is our repository again. So this is the link. So just go ahead and copy this link. Make sure this is the same repository you want to upload to. And once you copied the link, you can go ahead back to your terminal. And inside of your terminal, you will add this repository as a origin location. So we will use the command git remote add origin, and we will paste the URL. So this will basically add this particular URL as a origin in our system for this particular directory. So let me go ahead and press enter. All right. Okay. So we have added our remote repository. Now we can go ahead and push the changes we have made onto this repository. So we can use the command git push origin master. It will push it, but it will need authorization. Alright, so it's done pushing to this particular location from the master branch onto the repository. So if we go back to our repository over here and refresh, we should see the new code over here. So we have index.html appearing over here. Alright, so there was one commit made to it. You can go ahead and click on that commit. You can see the commit history. There is only one commit made to this. We come back over here and we click on index.html. And once we click on index.html, we can see our code over here, right? Okay, now let's head back. We have uploaded our file onto the system, and you can see that it's onto our local remote repository, and you can see it's been added. And the commit is also over here. All right, so now let's do another thing. We have done this once. Now let's try to make more changes and upload the newer file, right? So what will happen in that? So I will go ahead and open my index.html again. And over here, I'm going to add a paragraph tag. I'm going to close this tag. I'm going to save this with Control O, Enter, Control X. I will verify if I've made the changes. All right. Now I'm going to go ahead and stage this file. Now let me show you how it does, staging. So first we will create another file, hello.txt. If I do an ls, you can see there are two files, but I will stage only index.html. All right. So if I do a git status, yeah, there is one untracked file, that is hello.txt. So any changes made here into this hello.txt they will not be recorded. So once we have committed our index.html, we can go ahead and commit it, git commit m message added p tag to index.html. A relevant message, always add a relevant message, then press enter. So you can see that one file was changed and 3 insertions were made. Okay. So if we do a git status again, it will tell us that one file has not been tracked, but our index.html has been staged and committed. So I will do git. You can see nothing added to commit. All right. So git push origin master. All right. So it pushed all of the changes I made onto the remote repository now. So if I reload the page again, I will see that there are now 2 commits. If I just look it up, you can see the latest commit always appearing on the right hand side. There are 2 commits. Added index.html, added p tag to index.html. Right? They have their own commit ID. You can go back. You can open index.html and you will see the changes that have been made. Okay. So this is how you would go ahead and version it. You can always go back to a previous commit if you want. We can go back to the older version if you wanted. Right? Right. We have our older version. So this is why Git is useful. You can do a lot of things, especially go back to older commands. If I come back over here, I want to show you guys one more thing. It's the git clone command. To do that, I will come out of the project directory, our working directory. I will create a new directory, mkdir, call this temp, and I will head inside temp. Now, once I head inside temp, I'm going to go ahead and use the git clone command. So this basically clones any person's repository onto your local system. So if I go back to code, I click on code over here, copy the URL. You can do this with anyone's code. You can go ahead and do this with my code also. Just go, it's public, so you can copy this, come back, use the git clone command, and then paste the URL, and then press enter. Okay, so if I do an ls now, I can see my demo website is created as a working directory. So let me just go inside here. And if I do an ls, I can see the index.html. All right. Now I want to show you guys one more command. We will head back to our project directory. And over here, we will use the command called git log. So git log basically gives you an idea of how many commits were made. So if you wanted to add one more commit, you can see all the previous commits. Added index.html, added p tag to index.html. If you wanted to add another commit, so let me just go ahead and quickly add one more thing to index.html. I'll paste this. I will commit this. One insertion was made. If I do a git log again, you can see the new commit has been made. But you can also see that this origin master. So this means that this one has been pushed onto the remote repository, whereas this has not been. Let's quickly do that. Git push origin master. Alright, so now we are done. Now there is another command called git pull command. It is exactly like clone, but clone is generally used in the starting when you have a fresh new start. That's when you use git clone. And git pull is generally used and it's better to use when you are pulling from a main repository. Git pull is if you are working with a team and you need to update whatever code you have. Suppose this is my master code index.html, but a lot of more people kept on adding to the index.html, not just me. So I want to pull these onto my system. So what will I do in that case? Instead of using git clone, I will go ahead and use git pull command. All you have to do is write git pull and copy the code and paste it. Press enter. All right, so it's already up to date. That means everything is already added. So if somebody added another file over here called hello.html separately, you can go ahead and use git pull and it will merge all of it in your local repository, right, with all the changes you have made. All right, so guys, those were the git basic commands. Now let's move on to the next topic. We have git branches. So let's study git branches. So what are branches over here? Now we have you might have some idea of what branches are because I've told you about master branch, right? So branches basically allow easy management of different parts of a software. For example, let's say your team is working on delivering a website. Now, this website will have different features, right? Each of these features will be counted as a branch within Git that will be worked on separately by different developers. Once they are done with their work on the corresponding branches, they will issue an PR, a pull request, and then the branch will be merged onto the master branch on the Git repository. So the master branch will be the one that goes into production. This sort of falls into the idea of changing a small part of that old code without affecting the whole code at large. You can imagine branches as separate timelines. So let me show you guys with the diagram. So we have a master branch over here. We have made some commits and we decide to create a feature one branch. So we have created a feature one branch over here, and feature one branch will have its own commit as well as feature two. So you can see feature one was pulled from the master at one point, and they made the changes, and then they merged it back onto the master branch. And then similarly, feature two branch we have over here, feature two branch, pulled from the master branch. They made their own commits and then they merged it later on. So the latest version of master will include both feature one and feature two, whereas the earliest version will not. So this is how branches work. They're basically like timelines where you can work on different timelines and then merge those different timelines together. Now, each branch has its own unique commit, right? So these commits are basically like checkpoints that are created whenever you use the git commit command to save the changes, like we studied. They are also created when you merge the branches. So when we learn about merging, I'll talk more about merge commit. So basically, what that means is that you whenever you merge it back onto a master branch, there's a commit created. So these circles are basically commits. All right. So these are branches. Let's see few common commands to work with branches. Let me come back. Git branch is one of the very common commands. It basically tells you all the different branches in your system in the local repository. There's only one branch, that is master branch. So make sure, so to create a new branch, we will go ahead and use the command git branch, and I'm going to give this a name, feature one. Let me give it a proper name, git branch feature one. So if I do a git branch again, I should see two branches, but you can still see that I'm on the master branch and feature one branch I'm not there on. It's there in the system, but I'm not on it. All right, to go to the feature one branch, what we can do is you can use the command git checkout. So git checkout will basically help you to go to the other branches. So git checkout, switch to branch feature one. If I do a git branch again, you can see that I am switched to feature one as a branch. Now to delete a branch, right? So make sure you first come out of a branch. So let me check out master over here, and I will create another branch, feature two, and I will go ahead and delete feature one branch. To do that, I will use the command git branch hyphen d. And when you use the hyphen d command, just go ahead and type the name of the branch you want to delete, feature one, deleted branch, feature one. So if I do a git branch again, I can see that feature one branch is not there anymore. Now this command won't work if you are deleting the branch you are currently in. Now you can rename a branch also. So let's go to feature two branch and rename it. Git checkout. You can only rename branches if you are in those branches. So that's why I have to go to that branches, feature two. And now I will rename it using the command git branch hyphen m and the new name. So the new name I'm going to give this is feature B. Alright, so if I do a git branch again, I can see feature 2 has changed to feature B. Alright, so if you suppose pulled a branch, right? So if you cloned a specific repository from somewhere, so suppose if you clone this repository and there are two branches, you won't see those branches because they're remote branches. They're not local branches like these because they're over here. So to see all of them, you have to use the command git branch hyphen a to list all the branches, right? So it will appear in red just like here. Okay. So there is a shortcut for one of the things that I want to tell you guys. So if you want to create a branch and switch into it directly, just use this command git checkout. Let me just switch me. And then type in hyphen b and then create the branch. So feature one. So this will create feature one from me and it will switch to feature one for me also. You can see the branch changing over here also. So if I do a git branch again, you can see all the different branches over here, right? Let me just go back to the master one. Just remember the master one is the most important one. Don't delete this one. All right. So now let's go ahead and talk about the next topic, that is merging. So merging is important because you have different branches always. You're going to have multiple branches and you would want to learn the concept of merging. Git merge allows a user to merge different branches into one. It will create a new commit on merging. Here, the history of commits are not transferred. So that is important to remember. So let's take that example of our image again, the diagram. We have master branch, we have feature one, and feature one, you can see has different commits over here. And in this feature one branch, you can see that when it gets merged back onto the master branch, there is a commit merge commit created. So this is basically merging. Every time you merge a branch back onto the master branch or any other branch, there is a commit created on the receiving branch. So feature one branch is the committing branch, the joining branch, and master branch is the receiving branch. Similarly with feature two, you can see when the feature two gets merged back onto master branch, a merge commit is created. So here you can see that any of the features, any of the commits that are made on feature one branch or feature two branch aren't transferred. Only a unified history of them is transferred to the master branch, not all of them. So, merging is good, but it's not really best if you have a project where there are way too many people working on it because, you might have way too many merges. Now, we'll talk about that more when we talk about rebasing. So let's go ahead and try merging some of the branches here. Alright guys, so to learn about merging, I have created a new directory over here. We're going to call this my project, and I have written a new file. It's called base.py. It's a Python file. So if we open it up, let me just show you the contents of it. We don't need to open it up. Right, so it's just main code. I'm just trying to simulate that this has the main code. Now what we want to discuss here is how the merging will happen and what kind of branches are we creating. So guys, we're going to create two branches. To create those two branches, let me first stage and commit this file. I will quickly do this and edit. Alright, so we're done doing that. So let's say that there are two developers, developer A and developer B. So these developers are going to be working on this particular project, and their jobs respectively is to basically create features A and features B. So let's go ahead and create those branches for these developers. If I do a git branch right now, we can see all the three branches, the master branch which has the main code, then we have feature A branch on which developer A will work, and feature B branch on which the developer B will work. Right now we are on master branch. You can check, you can figure that out by seeing where the star is, or whatever is next to your directory. So this is what it tells us. Now let's go ahead and see how developer A will work. So right now, if we check out feature A, my bad, let me go ahead and, yeah. So we are in feature A, as you can see with this. Now, if I do an ls over here, you can see that base.py has been copied to it. Now the developer is going to basically create a new file. So let me nano it, feature A.py. So he's basically going to write the code for feature A. He's going to go ahead and save this. And let's say that the developer B is also going to do the same. So we will head to feature B branch. And over here, we're going to go ahead and create. Let me show you that we only have the base file. Right. So we did not stage and commit this. Let's go ahead and stage and commit the file in feature A, because if you don't do it, it will appear in all your other branches. So this is a warning for you all. So just go to feature A. Always do a git status if you're not sure before you changing your branches. So over here, what you can do is you can go ahead and type git add to stage the file, and then git commit to save the file. All right, so we have committed the changes. Now, if we go ahead and check out feature B branch, we are not going to see the file. We're only going to see the base.py. And if I list the content, there's nothing new in this. So let's say that the developer B is also going to write feature B.py. Let's go ahead and do that. Feature B.py. Let me open it up using the nano editor. And over here, we're going to write some code for feature B. Let me save this. Let me go ahead and stage this so that doesn't appear in other branches. And then we will commit this. All right. So now we have done doing that. If I do an ls, you guys can see the file. And if I head back to my master branch, you guys can see only base.py is over here because those developers were working on their, separate branches that were isolated. Nothing was being exchanged. The only reason it was exchanged because, we didn't commit it, right? So now we will go ahead and merge our feature A branch with a master branch. This is to signify that the developer A has finished working on all of his work, and now he's going to merge whatever he's done onto the master branch. To do that, he will use the command git merge. So we will go ahead and write git merge, and we will write the name of the branch that is going to be merged, that is feature A. So whenever you want to merge a certain branch, right? So two branches, go to the receiving branch. In this case, it's going to the master branch that is going to receive the merge, and write the name of the sending branch, or the branch that is being going to be merged. So we're going to write git merge feature A, press enter. All right. So here, if I do an ls now, we can see feature A has now been copied onto the master branch. But I want to show you guys something. If we write git log over here, we will see that there is no commit, there is no merge commit. So I've told you guys that every time you do a commit, every time you do a merge, a commit is formed. But right now there is no commit, no merge commit formed over here. Only the commit from the feature branch has been transferred over to the master branch. So this is basically called a forward. So forwards basically happen when there are no changes made in the earlier branch. If the history of master branch is it's similar to feature A, as in if no changes were made to master while feature A was being changed, then this fast forwarding can happen. So if in case we had added something else to base.py, or if we added a new file altogether to master, and then we had merged feature A to master, then we will get a merge commit. Only then a merge commit happens, right? So we can see that when we merge feature B onto master. So let me go ahead and do that. Git merge feature B, and I will press enter. Right. So now you can see that it's asking me for the message of the merge commit. So over here, this is going to be the message of the merge commit, merge branch feature B into master. And to save this, or if you want to write anything, go ahead and press insert and enter whatever you want. Since we don't want to enter anything, we will just backspace whatever extra we added. And we will go ahead and remove the insert by pressing Ctrl C, then pressing Shift colon and pressing WQ. So this will write this commit message and then exit. So you can see that a new commit has been created. And if we go ahead and do a git log, we will see a new commit over here. That is the merge commit. Merge branch feature B into master. Now this didn't happen when we did with, the same thing with feature A, because it was a fast forward. We we didn't really need to do anything because master hadn't changed at all since feature A was being merged. But when we were merging feature B, there was a new change in the master. There was a new commit in master, and that's why we needed to do a. That's why a merge commit happened. So if you want to end, exit your git log, just press Q, and you will automatically exit. So guys, this is how your merging basically happens. Okay guys, now I want to talk about Git merge conflict. When do they happen and how can we resolve any Git merge conflict? So let me go back to the terminal over here. So I've created a new directory to explain this to you guys. It's called the temp directory, and we're gonna go ahead and create a file. Actually, I've already created a file over here called hello.py, and I've already staged and committed it over here. So git log, you can see the commit. Now we're going to go ahead and create two branches again. I'm going to name this feature, I'm going to just name this P1 and P2 for convenience sake. So these are feature 1 and feature 2 branches. And if I do a git branch, we can see the branches over here. Alright, so we have two branches. Let me go to feature 1 branch. And if I do ls, we can see the hello.py file over here also. So guys, we want to simulate a merge conflict. So when does a merge conflict happen? To understand that, let's assume that we have three branches over here, and feature 1 branch is being developed by developer 1 and feature 2 branch is being developed by developer 2. Their jobs are respectively to create feature 1 and feature 2. While they're doing it, some third developer or maybe the team lead adds a new hotfix to the master branch. So let's go ahead and add that. So in master, I'm going to create a new file over here. Actually, let me just edit the already existing hello.py file. We're going to add hotfix code over here. All right, hotfix code has been added. So let me go ahead and commit this. All right, so we added the hotfix. Now we will go back to our feature 1 branch, and in feature 1, our developer is going to add the new code into the hello.py file. So he wants to add his own code. So he's gonna write over here feature 1 itself. Let me go ahead and save this, and we will stage this. Then we will commit this. All right. So he's committed it. All right. So now what he wants to do is he realizes that the master branch has new code in it. So to run the code on his system, he has to basically merge the master branch onto his own system. To do this, he will go ahead and do a git merge in his branch, that is feature 1 branch. So once he does that, git merge master, all the basically contents of master will be joined into the feature 1 branch. So if you press enter, you can see that there is a merge conflict in hello.py. Now, the automatic merge failed because there are some conflicts within the same code. Because why? Because in our hello.py in feature 1 has different code than the one that is there in master. The master has the hotfix code, whereas our file does not have it. Now, generally, your merge conflicts appear because of sometimes developers may work on the same file, and once they do work on the same file, they might push it independently, and the other developer might not know about it. So he realizes that mistake, so he pulls the code, and then he will go ahead and get this message of the merge conflict. All right, so we can see that there's no commit found here because we haven't resolved the merge conflict. To resolve the merge conflict, we will go ahead and use the vim diff tool. To go ahead and access that, we will use the command git merge tool -d vim diff. So this will allow us to basically see what are the differences in our code and basically resolve it into a final file. Let me just press enter, and it will open up the editor for us. All right, so here is the editor. We can see the two files over here. This is the feature one. This is the hello.py file in the feature one, and this is the hello.py file in your master branch. And this is what is going to be our main file. So we can go ahead and edit it over here. So you can see there's some extra things. We can remove them. What we will basically keep only those things that we desire. So we only desire feature one and the hotfix code to be in a file. So we will go ahead and delete all of these. So once you recognize your desired file, or made your desired file, all you should do is basically press shift colon and then write wq. So it will write it and then quit this file. For all the other files, you can just go ahead and shift colon and q. You don't need to save any other file here from here. All right. So once you do that, you can press ls and you will see that the two files hello.py. You can go ahead and remove this file. You can remove this original file. You can go ahead and keep this file itself. So if I cat the new hello.py file, I can see that the main code is over here, the feature one file is here, and the hotfix code is also here. But we still have to, basically create the commit. The commit has not been created, so we have to do that manually. So I will write here git commit -n merge master to feature one branch. All right. So you can see that this is back to normal. If we go back to master, and if I do git log over here, you can see that there are no extra commits because there were no extra commits made in this. There were commits made in feature one. Now let's see what happens when we do the same thing in a feature two. But before that, the feature one's new file has to be merged back into the master, because the feature one has to be merged back into the master because the developer one has done with his work, so he will merge it back to master. So we will type in git merge feature one. So you can see the fast forwarding is happening because basically the commits are similar because these two files have the same base. So basically it just did a fast forward. All right. So if I cat my hello.py file over here, I can see that the feature one is there. All right. So now let's head to our feature two branch. In our feature 2 branch, if I do a cat of hello.py, you can see that only main code over here. So developer 2 will start working on this code. So let's assume we are developer 2 and we add the new code, feature code for feature. We'll save it. Then we will go ahead and stage it and commit it. Alright, now that we've done that, we will go ahead and merge the original branch. Now, instead of developer 2 writing the new code in the starting itself, he could have merged the original file and then started working on it. It's his wish, however he wants to do it. So we will go ahead and type in git merge and then master. So all the contents of master will be merged with feature 2's content. So let's press enter. We're getting again a conflict because the master branch has different content than your feature 2 branch, and they don't have a common base because there are more commits in master than in feature that feature does not recognize. So let's go ahead and use our merge tool, git merge tool -t vim diff to get our desired file. All right, so we will go ahead and edit our file to get whatever we want. We'll remove this greater than and head these equal to kind this master. So we have code for feature 2, feature 1, hotfix code, and the main code. So we can go ahead and save this. So shift colon WQ and Q for the rest of them. No need to save them. Alright, you know the drill. Just check ls and we see the remove the original dot original file. rm -f hello. All right, so we have hello.py. Let's just check it to make sure that it has all the content. All right, so this is how you would go ahead and resolve any merge conflicts that you face. Now let's move to the next topic. It's called rebasing. So rebasing is very similar to merge. Now the git rebase basically allows a user to shift a set of commits and give them a new base. It is similar to git merge, but the difference here is that the history of commits of the branch is also carried over when it is joined with the current branch. So basically you have your master branch, and from the master branch you create a new feature branch, and in that feature branch you make a few commits. And once you make those few commits, you don't merge it back into the master branch, you basically rebase it. So what you do is you copy the commits over here, and once you copy them, you paste them onto the master branch. You extend the master branch and you paste them over here. So it's like, shifting the whole set of commits onto the master branch. So it's pretty cool. So it's not same to merge where a merge commit is created. You are just basically shifting the whole set of commits, but you're not shifting the same commits. You're creating new commits that have the basically the same history as the feature branch commit. So the reason that a rebasing may be used instead of merging is when you have a file or when you have a project where a lot of different team members are working, where you have a very busy project where you have hundreds of developers, pushing and pulling and pushing and pulling the code from the master branch. So this creates a lot of unnecessary merge commits. So merge commits can basically clog up the pipeline when you want to investigate any issues. So in that case, a lot of people use rebasing. So it's a lot more cleaner. The history is, it's not unified into one commit. You have the history clearly put out in the master branch itself. So people can go back and look at the history without having to go into any of the smaller branches. So they can just view the master branch and be sure of whatever they wanted to look at. So that's why some people prefer rebasing, and it basically, it's a requirement based on particular situation. All right, so now let's go ahead and learn how to rebase. So let me come back over here. All right, so we have the temp directory again, but I have a different file over here. It's the main.py. Let's see the contents of it. It's just main code. Now I want to show you guys how rebasing works. So what I will basically do is I will first also show you the git logs to show you that there is only one commit right now, that is called added main.py. That is the commit for the master branch. So we will go ahead and create a branch called feature. I've used feature way too many times to give you guys a better idea. Let's say the other branch's name is develop. All right. So git branch develop. And then we will go ahead and check out the develop branch. Now, once we're inside the branch, let's make sure that our main.py file is over here. And in the develop branch, we're going to add one more file. Now, let me go ahead and give this the name hello, or let's guess this name kitty. Yeah, kitty.py. Inside of this, I'm going to write kitty code. All right, so let me go ahead and save this. Then we will then we will stage it, and then we will go ahead and commit this. Now I'm gonna basically to help you guys identify, I'm gonna give this hash over here so you guys can identify when we do the rebasing. And now I will write the code commit statement. Oh yeah, right. I'll just remove the end git commit added kitty dot py file. All right. So let's make one more change. I'm gonna go ahead and make one other change into kitty.py. I'm gonna add doggy code. Alright, so let me go ahead and save this. Then we will stage it, and then we will commit it. I'm gonna add the hash again so you guys can identify easily. Added doggy code to kitty.py file. Alright, so we made a lot of commits in our develop branch. Okay, so let's just use the git log command. Yeah, so we can see that there are, basically three commits. That is one from the master branch, and the other ones are your develop branch commit. Okay, so now let's go back to the master branch. Git checkout master. In our master branch, if we do a git log again, we see only one commit is over here. Now let's go ahead and rebase our master with our develop branch. So remember guys, what basically is happening is that we have one master branch and the feature branch is getting merged onto a master branch. Only difference from normal merging is that all of the commits, both of the commits that were made in feature branch will be copied onto the master branch. So let's go ahead and use the command git rebase and the name of the branch. So that will be develop. So you can see that it's successfully rebased and updated. So if I clear this and if I do an ls, and remember this is in my master branch, I should see kitty.py. If I do a cat kitty.py, I can see all the kitty code and doggy code. Alright, so we have successfully merged it. Now if you look at git log, you will see the actual difference. You can see in our master branch itself, we have the extra two commits and you can see the hash also. And that helps you identify that these are part of the develop branch and not the master branch. So this is what happens with your basically rebasing. So I hope you guys understood what rebasing is. Hope you guys have been enjoying this session. If you have any suggestions, we would love to know them. So please go ahead and put them in the comments below and we will reply to you as soon as possible. And now let us continue with this video. So the next concept is called Git Workflow. So guys, basically when you're working in an active software development company, a lot of you guys already might have some idea about it. You don't basically have a single or a very simple architecture like how we use to practice all of the git merge rebasing commands. You have a lot of different branches because you'll be working with a lot of different people and there has to be a hierarchy maintained in a very organized manner. So Git is a powerful tool and leveraging it effectively in software development is very important. This is where the approach of Git workflow comes in. Git needs to be designed. So you need to design a perfect workflow that suits the needs of your team as well as your organization where you're able to deliver the perfect product with a complex architecture that basically complements that perfect architecture, that perfect product, right? So you can see over here, this is just an example where you have master, hotfix, release, develop, and feature. So all of these are different branches. So let's say that master branch is started out with version 0.1 and feature basically is a branch created of the master branch. Actually the develop branch is created of the master branch. So we have the develop branch. So this branch is where basically all of the features are merged onto. So if you have feature 1, feature 2, feature 3, all of them will be merged onto the develop branch. It contains all the functional code that will be responsible for running the software. And once all the features have been merged onto the develop branch, it can go to the release branch. So let's actually go through this one by one. So we have version 1 and it's made so a branch is basically created out of the master branch, that is the develop branch, and from the develop branch we make a commit and then we create the feature branch. So feature branch will, this is basically representation of all the features that there might be in your software. This branch is the one that most developers will be working on, and any and all of the features of the software are coded in these branches. So the developers will pull from the master branch into their local systems, then create a pull request and do their work, and then when their work is done, they it's reviewed by the senior member, and if it's approved, then the branches merge onto the develop branch, and then your develop branch basically contains all of the different features. And once all of the features have been merged onto the develop branch, then the develop branch is merged to the release branch. So this is the branch where all of the code is reviewed for extra bugs. Release preparation is done and the documentation is completed in this basically branch, and then the release branch is merged onto the master branch. And once it's merged onto the master branch, you have your version 0.2, and the version 0.2 can go ahead for deployment. But the thing is, if there are any issues that were overlooked in your develop branch or release branch or feature branch, they can be fixed using a separate branch called the hotfix branch. So this branch, as the name suggests, is used to make quick fixes to the code. This branch allows for the workflow interruption. This allows for basically, no workflow interruption, and you can resolve any bug without doing that. It is quick and it serves the singular purpose of solving the bug. And then we have definitely our master branch, where basically the code is tagged with a version and it's pushed for building purposes, testing purposes, and deployment according to a certain schedule that there might be, right? So this is how a Git workflow might work in an organization. This is a very generic one. All right, so let's go ahead and try and create our own Git workflow. It's going to be very similar to this. So let me just clear off the screen. So let me create a new folder for this. I will call this workflow. And then we will enter this folder. Alright. So once we enter this folder, I'm going to go ahead and initialize this folder. Right. And once I've initialized the folder, I'm going to create the first file, nano main.py. Inside this, I'm going to write all of the main code. Save this, stage this file, commit this file, added main.py file. Alright, so once we've done that, we can go ahead and create our other branches. So first branch I'm going to create is feature A branch. Then I'm going to go ahead and create feature B branch. So they're going to contain features A and features B respectively. Then I'm going to go ahead and create the develop branch. Alright, so we've created the develop branch. Then we will create the release branch. Alright, so we have created almost all the branches. I will create the hotfix branch in the last. So let me just show you guys quickly how it looks like. Git branch, and you can see all of the different branches over here. We have develop, feature A, feature B, and release and master. Right, so we have some code in master. Let's also go ahead and tag that code. And I will initialize this code again. Sorry, stage, commit the code. Alright, so we are done doing that. Now we will move on to feature branch A. To do the admin. Alright, so we made one mistake. That was, basically we created all the branches without having the final code. So the code has not been copied. So let me just redo this quickly. So it was a good thing we didn't create the last one. Huh? Less work for us. Alright, so if I do a git branch again. Alright, so let me just create them again. I'm doing this because I had forgotten to basically update my main.py code. So let me just do that again. Git branch feature A. Then we will create feature B. Then we will create the develop branch. Then we will create the release branch. Alright, so we have created all the branches we want. We will also create the hotfix branch in the end. Alright, so let's go to our first branch, that is feature A branch. So the developer A will be working on feature A branch. He will be working on, that is main.py file. So this is the version 1. So his job is to basically add extra features. So he will add feature A.py code for feature A. Let's stage it, commit the code. So once the developer is done making all the changes in feature A, he will go ahead and commit the code, added feature A. Alright, so he's done doing that. Now we will move on to feature B branch, and we will do the same thing over here. We will create feature B.py. So this will be worked on by developer B. The code for feature B. Let's save this. Then we will perform the same acts again, basically staging the file. Then we will commit the file, added feature B. Alright. So let me just change this commit. We keep on adding that n. I shouldn't be doing that. Right. So we have basically added our features, right? So our next step is to basically merge these features onto the develop branch. So the developers are done working on their code. Now their job is to basically merge these branches onto the develop branch so that this, it can be reviewed by the team leads or the senior developers. So to do that, we will head to our develop branch, and over here we will use the git merge command. So let's just show you guys that there is no other code over here. Then git merge feature A, then feature B, right? Okay. So if I do an ls, we can see that feature A and feature B are over here, and our main.py code also here. So these basically this code will be reviewed, and if the code is deemed successful, then it will move on to the release branch, right? So basically we have a functional software. So this basically makes a functional software. Now this will move on to the release branch. So on the release branch, right, we will move to the release branch, and we will go ahead and merge our develop branch. You can see that the fast forwarding is happening. Alright, so we have all the things we need in our release branch, and all of our code is over here. Now, it will sit in the release branch until the scheduled date comes for, for pushing it to the, for building purposes, for testing purposes, and for production purposes. And all the documentation will happen, and all the rest of the extra bug checking will happen. So once all of that is done, right, so it will be merged back onto the master branch. So let's go ahead and do that. Git checkout master, and we will merge release branch. So let's suppose that this is the date it was scheduled for the basically pushing. So this is what we are doing. All right. So if we check our master branch, it has all of the new features now. Okay. So basically now the code can go ahead for, basically building purposes, testing purposes, and production, for the go to the production environment. So our job here is basically done. We have created a successful Git workflow. We are missing out one branch. So that, branch is usually used when there is a quick fix needed. So suppose, there was some issue in feature B.py that was overlooked by everyone. We will go ahead and create a hotfix branch for that. And let's check out the hotfix branch. And if I do an ls, you can see all of the features already here. Now in this, we can go ahead and change. So inside feature B, they wanted to change the code. So we will write over here, code was changed in hotfix. Alright, so let's save this, let's exit it, and we will go ahead and stage this and commit git commit message added hotfix to feature B. Then enter. Alright, so our work here is done in feature, that is our hotfix branch, and we will go back to the master branch and merge hotfix onto the master branch. Git merge hotfix, and there we are done with the whole workflow. So if I do ls over here, we can see our feature B again, and if I list the values, you can see the values are here now. Now guys, I want to show you guys how it might look, all the commits, how it looks. If I do a git log in master, you can see a lot of the things over here. Let me show it you in a graph form. So we can do that. Git log hyphen hyphen graph. You can see the graph over here. So this is what it looks like. We have one master branch and we have a lot of other branches coming back and committing and merging onto our master branch, right? If you wanted to see it in a little better way, we can go ahead and use another flag called online. Sorry, one line. Yeah. So this is how it looks like. I hope you guys understood how the workflow works and it was helpful for you guys. Oh, one more last thing I want to leave you guys with is a command that is called git pull. Now, git pull is the one that you guys will be mostly using a lot, because instead of git clone is originally used when you want to clone a specific, repository from remote cloud onto your system. But once you've done that and you want to update that, the whole file you have, if you want to update that whole master branch you have on your local system, instead of cloning it again into another location, you just pull again from the remote repository. If there are any changes made onto the remote repository, you basically pull it and it will update your local repository after you use the git pull command. So that's how your git pull command.
So guys, that was our video on Git tutorial. Now you guys have enough skills and understanding to go ahead and version control any software source code by yourself with the help of Git. And again guys, I want to tell you about Git Learning Academy, where you can go ahead and register for any course and earn yourself a free certificate. Thank you so much for watching.